Hello, welcome to Chapter 5, Section 2. In this video, we're going to be doing problems 5, 6, and 7 on page 328. Of course, that's the PDF, page 19. So, we are going to look for the properties of these quadratic functions if the function is written in standard form. We're first going to figure out if the graph opens upwards or downwards. We're going to then find the axis of symmetry. Using that, we're going to find the vertex, and then we're going to find the y-intercept. We are not going to graph it. The first time, I'm going to graph it using the calculator. But you are more than welcome to use Desmos or any of the other technology to graph these. And I'm not going to worry too much about graphing them by hand. Actually, what I think would be better would be if you were to actually graph it. So like here's the graph of this one. Yep. And then as you see each of the properties, we can figure out if it actually does match up. This is negative x squared minus 2x minus 8, right? So that's what the graph is. So after I find out all the properties, I'm going to look and see if that's what it shows up on the graph. All right, so first thing I have to do every time is figure out what my parameters are. My a is negative 1, my b is negative 2, and my c is negative 8. First thing, and don't worry about the fact that that's also a, b, c. Okay, I know that's confusing every time I teach this. These are the parameters, those are just the steps. Don't worry about it. We also have an a there. Okay, don't be concerned about that. First thing, my a is negative 1, so that means that my graph is going to open downwards. So it is a frowny face and looks like that. And the reason is because a is negative. It's negative 1. You can also say because a is less than 0. Or you can just say because a is negative. Any one of those things are good enough for me. Just as long as you tell me you know why it goes downward. Now let's look at our graph. Can you guys even see that? There it is. It does open downward, so yay. Next, let's find the axis of symmetry. The axis of symmetry is x equals b over negative 2a. My b is negative 2. Might have to get a different marker. This one's starting to dry out. My a is negative 1, so negative 2 times negative 1. There it goes. Negative 2 times negative 1 is positive 2. And negative 2 divided by positive 2 is negative 1. If you just leave negative 1, I will count it wrong. And if you say, why did I get that wrong? I'm just going to repeat this over and over again. The axis of symmetry is x equals negative 1. Now, here's the problem. There is a way to do this, and to be honest, I don't really use the TI-84s that much for graphing anymore. There is a way to do this where you can graph vertical lines, but I forget how to do it. So if you think about my vertical line starting here at negative 1 and going that way, it does look like that is my axis of symmetry. Okay, I'll probably mention in class if I remember how to graph it. All right, but if you go to Desmos, just type x equals negative 1 and it does it for you. I probably should have used Desmos instead. Who knows? Okay, now I want to find the vertex. My vertex, this is the x value of the vertex, okay? So in other words, this right here, the x value, which we call h, remember, h is a parameter, okay? That's all it is. It's not a variable, it's not anything, it's just a placeholder. That h is negative 1, and I want to find hk, that's my vertex. So I have to put that negative 1 into my function. F of negative 1 equals negative, the opposite of negative 1 squared, subtract 2 times negative 1, subtract 8. Negative 1 squared is 1, and I get negative 1. There's a lot of negative 1s there, okay? Take care of the exponent first. This is negative 1 times negative 1, which is positive 1, and the opposite of that is negative 1. Negative 2 times negative 1 is positive 2, subtract 8. And then, however you add this up, the associative property says pick any two to get started with. It doesn't matter. I could do 2 plus -9. Whatever you want to do. Either way, you're going to get -7. So my vertex is -1, -7. And that looks correct. Looks like about right there. Again, the TI-84 doesn't let me plot just one point. Okay, I can do this. I can trace. I'll see if I can do this. And then move that over. It just doesn't get there exactly. So if I round it off, I get -1, -7. And that's really close to the vertex. But the TI-84, that's why we don't use TI-84s anymore. Finally, I need to find the Y-intercept. Well, the Y-intercept is just that number right there, -8. And if I look at it, so here's 0, -8. That one did land exactly where I want it. All right, cool. Let's do a couple more. And again, if I'm going too fast, please pause it, rewind it, do whatever you need to do. And I will take pictures of all these things so you guys can see it. Okay, g of x is x squared subtract 3x plus 2. So my a equals 1, my b equals -3, and my c equals 2. First, it opens upwards like a smiley face because a is positive. And again, you can say because a equals 1, or you can just write a is positive. Next, the axis of symmetry. X equals b over -2a. b is -3. a is 1, so -2 times 1. Negative divided by negative is a positive, and I already did 2 times 1 is 2. Sorry, I did it, but I didn't say it. -3 divided by -2 equals +1.5. You can leave it as a fraction if you want. I'm probably going to use a calculator, so I'm going to use 1.5. Do not leave it as 1.5. Write x equals 1.5. Now let's find the y value. So I'm going to do g of 1.5. This is 1.5 squared. Subtract 3 times 1.5 plus 2. I'm going to cheat. 1.5 squared. Subtract 3 times 1.5 plus 2. I get -0.25, which is -1/4. So my vertex is 1.5, -0.25. And finally, my y-intercept is just that number right there, which is 2. Number 7. I don't like that they do this. I'm sorry. I won't do it for the problems that I write. They don't give it to you in standard form. They trick you, okay? You want to say a equals 4, b equals -1, c equals -1, but that's not right. See the x squared? You have to rearrange it. This is actually -x squared plus 4x subtract 1. Now it's in proper form. Highest exponent first, next highest. And this will make more sense when we do problems that have higher degree than 2. Right? You will see that they descend in order. But you got to switch these two. So my a equals -1, my b equals 4, and my c equals -1. It opens downward because a is negative. My axis of symmetry is b over -2a. That's 4 over -2 times -1. -2 times -1 is +2. 4 divided by 2 equals 2. So my axis of symmetry is x equals 2. My vertex. Now, you can use this if you didn't make a mistake. And I don't know how you'd make a mistake, but sometimes I do. Or you can go back to the original. It's a good habit to get into to always go back to the original. So I'm going to do h of 2 equals, and it doesn't matter, this is standard form, but it doesn't matter which form you use if you're trying to find the y value of the vertex. So I'm going to do 4 times 2, subtract 2 squared minus 1. And again, you can do it on the calculator, but this one we can do. This is 8, subtract 4, subtract 1. 8 subtract 4 is 4, 4 subtract 1 equals 3. So my vertex is 2, 3. And finally, my y-intercept is just that one right there, -1. And if you're doing all this, one thing you might want to do, I'm not using Desmos because I don't have access to another iPad to show you Desmos. I'm using my iPad to record this. But I'll do it in class. I'll switch over from one to the other. But if you guys want, take a moment when you look at these pictures, actually graph that and see if each of these things are true. All right, we'll see you in the next video.